this is the problem statement. A battery manufacturer claims that their battery lasts an average of 15 hours, and we are going to take one sample, that is the sample of 12 batteries tested and found to have an average life of 14.2 hours with the standard deviation of 2.5 hours. We have to found this using the t-test. So in this question they are given that the population value will be in 15 hours, and we are going to take a sample size which will be in for 12 batteries, and that our sample mean will be in value of 14.2 hours, and the standard deviation value will be in 2.5 hours. So first we are going to define what are the values which is given in the questions. So we are going to collect all those values first. So first I am going to find what is the sample size, which means this is the sample of 12 batteries is given. So which implies that the sample size will be in 12. So next we are going to take what is the sample mean for this 12 batteries. The sample mean for the 12 batteries will be in 14.2 hours. So the symbolic representation of sample mean will be in x bar. So the value of x bar will be in 14.2 hours. So next we are going to define what is the value for the population mean. So the population mean symbol will be in mu. So here the population mean value will be in 50. So the value of mu is equal to 50. So next we are going to define the standard deviation. So the value of standard deviation will be in 2.5 hours. So in the symbolic representation, the standard deviation, that is the sample standard deviation, will be denoted as S. So the small letter S will be in 2.5. So these are the terms which is given in the question. So next we are going to define what is the null hypothesis as well as the alternative hypothesis. So the null hypothesis will be defined as H0. So first we are going to define the null hypothesis will be in the positive case, which implies that there is no significant difference in the population, which implies the null hypothesis means mu is equal to 50. So this is the value defined definition of null hypothesis, that is there is no significant difference in the population mean. Here the population mean will be at 50, which implies the mu value which is equal to 50. So then in the ordinary hypothesis the denotation will be in H0. So ordinary hypothesis is nothing but this will be an opposite case of the null hypothesis. So the null ordinary hypothesis will be there is a significant difference in the population, which implies that the mu value is not equal to 50. So this is the alternative hypothesis. At last we are going to check whether the null hypothesis is correct or the alternative hypothesis will be incorrect. So this is we are going to find in this problem. So we are going to find this problem using the t-test. First we are going to define the formula for the t-test, that is between the sample mean as well as the population mean. So this is the formula for the t value, that is the x bar minus b divided by s divided by root n. So here the x bar means the sample mean, the value of sample mean will be in 14.2, and then mu means the population mean. So the value of population mean will be in 15, and the next the standard deviation value will be in 2.5, then the n value, n means sample size, the sample size value will be in 12. So I will substitute all those values. By simplifying this I get an answer that is the minus 1.11. So this is the value, that is the calculated value of t value, that is minus 1.11. But we are going to define the modulus of t. So then the positive, the negative term will become a positive term. So then the mod t value will be in 1.111. So this is the t value. So next we are going to find the degree of freedom. So the formula for the degree of freedom is n minus 1. Here the n value will be in 12, which is given in the question. So the 12 minus 1, the answer will be in 11. So this is the value for the degrees of freedom. So here there are no significance level is given. So I am going to find the significant level of 5% level of significance for this degrees of freedom level. So here for the 5% of degrees of freedom, the degrees of freedom will be in 11. So using the t-test table, the answer will be in 2.201. So we have to find these values in the t table. So in the t table we are going to find the 0.05 value for the degrees of freedom level. We obtain an answer that is the 2.201. So this is the critical value of this problem. So now we are going to compare the calculated value as well as the table value. So here the calculated value will be in 1.11 and the table value will be in 2.201. So we are going to comparing these two values. While comparing, our calculated value will be in less than those of the table value. So if it is less than, we are going to accept the null hypothesis. If it is greater than the table value, we are going to reject the null hypothesis. But in our case, our calculated value will be in less than the table value. So we accept the null hypothesis. If we accept the null hypothesis, means the answer will be there is no significant difference in the population means, which implies that the mu value which will be